Yeah, so as Ben said, a lot of my stuff is looking at how we can kind of um, diversify in different ways. And I think cover crops is a great opportunity there, especially in forage systems. I just want to make sure you can see my screen okay.
Looks great.
Perfect, thank you. And so today I'm kind of, well, as he said, I just started here at Iowa State this last year. And so my research is really just getting kicked off this year, but I really want to kind of give you why I think this is a great opportunity, optimizing forage availability with cover crop grazing. And so when I think about cover crops, I'm thinking about how they're implemented into a rotation we already have. We're generally thinking here in Iowa, corn and soybeans, it's a very common rotation here, or maybe there's wheat in that rotation. But how can we put another growing component in there to help break up that disease cycle, weed suppression, so many different things. And cover crops are really great at all these different kind of aspects. They're great at weed suppression. They some of them have that allelopathic effect, such as cereal rye, that help keep that um, weed seeds down. The competition, they outcompete, they smother them, close that canopy, don't let them have that opportunity to come out of the ground. They're also really great with reducing soil erosion, having that living root system or root system and residue on top of the soil, holding that soil in place. A lot of our topsoil, we don't like to see our topsoil blowing away in the wind, or really heavy rainfalls. The cover crops help keep that in place. We can help reduce compaction with those this types of systems. They with those root systems, turnips really great. That big bulb helping break up some of the soil. We can also fixate nitrogen. Nitrogen's a really expensive input cost that we have in our corn portion of the rotation. And so being able to get a legume in there, trying to grow that to be able to produce enough biomass that it's giving us some type of nitrogen credit. Some legumes are giving us up to 100 pounds of nitrogen per acre. That's pretty substantial. We are also looking at reducing that nitrogen runoff. Since we do have high input systems here, we're trying to reduce the runoff and getting into our waterways, down the Mississippi, eutrophication, all those types of things. So, the Iowa Nutrient Research Reduction Strategy estimates that just having a cover crop can help reduce nitrogen runoff by about 48%. So if we can, that is a huge impact that that can have. For the sake of this presentation, we're really looking at that forage production and quality piece. How can we maximize this forage production and quality while being able to graze? Grazing, a lot of people think grazing, oh no, we're grazing our cover crops. We're going to take every one of those other benefits away. And so, what does that actually look like? How can we graze these efficiently and say not compact our soils more or um, cause other problems. And so forage production is a great opportunity in cover crops. It can average anywhere 1 to 2 tons per acre. I've seen a lot higher as well. That's just an average. And so when we're thinking about grazing our cover crops, how often is this done? When is it done? Things like that. There was a study done by the Economic Research Services through the USDA that kind of took a look at this and they wanted to see okay, with our cover crops, how are they being used? And what I found really interesting is they looked at cow-calf producers, dairy, people that fall under other, so maybe small ruminants, and then people with no livestock, and how if they were using it for forage, if they weren't using it for forage. And what they found is that in every type of sector, they were using it as forage in some aspect. Cow-calf producers and our other producers seem to be grazing it more frequently than our dairy or our non-livestock individuals, but we're still using these cover crops as a forage quite consistently. And so that brings in a lot of different benefits by being to our producers by using this cover crop in another way. And so some of these benefits have been there's additional forage for our animals. Some studies have shown about a 2 to 3 pound average daily gain while grazing cover crops. Um, we're extending the grazing season, so we're not trying to push our say our cool season pastures into earlier into the spring or later into the fall where we may be doing damage. We have that cost benefits being able to use that as some type of feed source. We're going to start helping reduce the cost of putting that cover crop in the ground. And then also we have distribution of manure as we're grazing these cover crops. Animals are going to, instead of having to go out and spread it, we're going to have manure being distributed across the field. But with that, there are concerns that come along with using cover crops. And it's kind of like I mentioned before, is if we're using these cover crops as grazing, are we kind of taking away some of those other benefits that we had mentioned previously? Are we compacting our soils? Are we affecting our soil water infiltration? We also have infrastructure concerns. We have to be able to have a fence, water availability. And so some of those things are things that will have to be, that are kind of costly. Will we produce enough biomass? A lot of producers, the moment that they can get in the field, they're in the field trying to plant corn and soybeans, and they have a very extended season going out into late September and October. So we have a very short window in some of these rotations to be able to produce a high producing forage or cover crop. And then we also have some toxicity concerns. Unfortunately, most of our forages, there's some type of toxicity concern we just need to be aware of as we're trying to utilize these. And so it's kind of this balancing act, making sure that if we can graze them, how do we graze them in a beneficial way without taking away our other benefits? But also, we want to make sure that we're not impacting our row crop production very much because that is what we're trying to fit into to produce more. So we don't want to take a massive hit on that row crop production necessarily, especially if maybe we're renting to graze that cover crop on somebody else's land. Nobody's going to want you to be back there again if we are pugging up all the soils and things like that. And so this study, this is a what I'm about to show you here is a review article that basically wanted to pull different research that was happening on grazing cover crops and to truly understand what how grazing cover crops is impacting our soils, our crop production, water, etc. And so when they looked at, I believe it was 30 plus different studies across the states, and when they looked at compaction, which the two specific things that were looked at was bulk density and penetration resistance. And so what they saw is that there was an increase in our bulk density and penetration resistance in 55% of the studies that they saw. But what they noticed was very few of these cases actually were higher than what's 2 megapascals of pressure. And so what that means is that that actually does not inhibit our root growth. So when our compaction gets higher than that too, then we're starting to see root growth inhibition. So it's not able to get through that layer. They were able to stay under that for most of the studies, and the very few studies that actually saw that go across that too, it actually varied among years. So if they had a 5-year study, they might have seen it in year 2, but by year 3, that compaction was gone. And so they think there's a lot of different factors playing into this. Light tillage has shown to break up that compaction pretty easily in some of these cases, but the freeze thaw cycle of the ground is helping break up that light compaction that was caused by the animals. They also looked at water and water infiltration. We wanna make sure that our water is being absorbed into the ground, so that it's readily available to the plants that are gonna be growing, and so what they saw with this with grazing is it wasn't impacted. Um, they really didn't see an increase in water infiltration, and they did not see a decrease in water infiltration in these studies across the states. They also looked at total carbon and microbial biomass. This is really important in thinking about our organic matter in our soils and how this was being impacted. One of the things that's concerning is animals are grazing all of our residue. And so when they're grazing the residue, are they taking away, taking basically that organic matter that we're trying to put in the soils with those cover crops? Few studies did find a decrease in soil organic carbon, but these studies also had a really high removal rate. They basically removed all of the cover crops to about like 90%. So higher removal rates may be causing some of that. Um, but the majority of the studies grazing maintain our soil organic carbon across time. And one of probably the most important aspects in thinking about this is how is this impacting our crop production yields for the following years? And the majority of the studies did not see an impact on crop yields. There was one that did see an increase in crop yields and cotton, but for the majority, there was very few studies that saw a difference. And if there was, it was only noted it was varied among years. So the actual grazing of the cover crop was not impacting that crop production for the following year. All these things are really great to hear, but they also come with being able to graze properly and graze well. Some of that compaction problem they thought maybe have been caused by higher stocking rates, also wet conditions, things like that. So thinking about when we're grazing and how we're grazing. And so with that, that kind of shows that we have a really great opportunity with our cover crops used as a forage. And so that brings me into our next component. What should we select? Katja just previously was talking about all these different types of cover crops that we have, and she listed a bunch. There were just summer annuals that they were looking at, and they were looking at even more on the other end. And so our cover crops can be kind of placed in different aspects. We have our cool season cover crops. A lot of these, a lot of our common ones, such as our cereal grains, fall under this. We have our oats, cereal rye, winter wheat, triticale. These are all really great opportunities. Generally speaking, we're thinking about spring growth in a lot of these. We have our legumes that fall under our cool seasons, and then some broadleaf forbs such as our turnips and kale, some really quick growth cover crops. And then we go under to our warm season cover crops, which are a lot less often seen here in the Midwest because we're really thinking about that corn and soybean rotation a lot of times, but we should also be thinking about how we can implement them um, into our cycles. Now, this year, I've gotten a lot of calls about these actually due to all the flooding. What can we do now? Now that, say, I lost some acres, well, what kind of cover crop can I plant? Warm season annuals are great in the high heat of the summer. They take off very well. Again, we have our grasses, our legumes, and our broadleaves within these as well. And so, some of the things that we should be thinking about while we are selecting these, what is our winter survival? When are we expecting to graze? Because if it's not going to survive the winter, I would not want to be expecting to graze it in the spring if I planted it in the fall. Um, is it biannual, annual? How is that growth cycle? Where is it going to fit? I'm not really going to get in this to too much, but there is a lot of talk about that C to N ratio. I think it was just mentioned previously, shortly in the presentation before mine, how a high C to N ratio we could start seeing slower breakdown, and that could impact our next crop more. Where a lower C to N ratio is going to break down a bit faster, releases nutrients to the next crop faster. And so with that, we're thinking about this. One of the big questions that I always get asked is, do I do a monoculture, a pure sand, or do I do a mixture? And so there is a lot of research going on comparing doing a cocktail mix or a monoculture. And if you think about it, there could be benefits going either way. If we have a monoculture, there's an ease of management. We're only managing one crop. When we're thinking about a mixture, we're managing multiple crops, multiple seed sizes when planting, different things like that. So sometimes we need more specialized equipment to plant mixtures in comparison to a monoculture. Pure sand, we can, if we need to, we could have some herbicide usage. It may be able to play. This also goes into plant back restrictions. So depending on what you sprayed previously, how is that going to impact your cover crop? You could open up more opportunities in monocultures where mixtures we may end up hurting something that we just planted because of a plant back restriction. It's easier to select for your field site. You can make it really tailor it in sometimes with these monocultures versus mixtures. And then typically you see a more uniform cash crop the following year. So you'll see a more uniform corn stand or soybean stand due to everything across that field is going to be uniform. Now, just because it's uniform doesn't always make it great either. So it's a balance. Um, and so when you're looking at those mixtures, some of the big aspects that people like about the idea of mixtures is there's more flexibility in your selection, and most likely something is going to grow. There's something in that mixture. If it's a bad year, something's going to grow. There's cases where if it's a bad year and you grow a monoculture, you get nothing. But most likely in a mixture, something will come out. You'll have greater biodiversity, which that could increase biodiversity above and below ground, pollinators, bringing in beneficial insects. Again, you do have some more specialized equipment with these. And then the big selling aspect in some of these is it can cover more of your cover crop goals. And so with that, I think it's really interesting because a lot of times when we are looking at our cover crop goals, to be able to have one work, we need to have enough biomass of that cover crop grown to be able to produce um, enough nitrogen, enough cover for weed suppression. And so sometimes I think when we have mixtures, we start to actually dilute our control overall. And so this study was done by Florence and McGuire. It's basically looking at do diverse cover crop mixtures do better than monocultures? And so what they did is they compared 120 different studies across the US this was outside of the US as well. But they were looking at these and they said they noticed that 88% of the time the mixture was equivalent to the monoculture in whatever aspect they were looking at. And they had seven different aspects that they were truly looking at, and those are weed suppression, nitrogen retention, soil water, soil biology, biomass stability, crop yield, and cover crop biomass. And so each of those things, they were able to find a really well performing monoculture that could equate to the mixture. And then 10% of the time, they saw that the monoculture actually outperformed the mixture. And so there are different aspects of looking at this. But like I said, if we have 16 different cover crops in one mixture, we could be diluting each one of its components by its competing with each other and not getting enough. And one thing that I always think about when I'm thinking about mixtures is, say, pasture mixtures. We need 30% of our 30% dry matter for our legumes to be able to have the legumes produce enough nitrogen for our cool season grasses in that system. And so if we dilute out the legumes too much, we're not going to see that benefit. And so we need to be thinking about if we are making these mixtures, how do we make them well that we are receiving the benefits of each component of that mixture. And then the study also found that 2% of the times the mixture did better than the monoculture. And so it is, like I said, it's a balancing act of trying to figure out what that right balance is. And it also can change from farm to farm, farm to farm, location to location, and your environment. Uh, One mixture may do really well on a farm in Iowa, and in a farm in Nebraska, that mixture may look completely different because a different component of that mixture perform better in different environments. And so, really, if we're thinking about these mixtures, we need to be thinking about what our goals are and how can we achieve those and making sure we get enough biomass from those components to be able to achieve those goals. And so this is a little bit more on that article. And so here we have the cover crop monoculture treatment performance. So everything on the x-axis is looking at the monoculture, and everything on the y-axis is looking at the mixture. And so for the sake of this presentation, I'm really concerned about that biomass because if we don't have enough biomass, we don't have enough material to be grazing and to be for the animals to consume. And so in this case, what they saw, so the black, basically when it is black, it means there was a significant difference between the monoculture and the mixture. And everything that's in a little bit lighter of a color, that means they were similar or there wasn't data sufficient to support one way or the other. And what we can see here is that if we're looking at the biomass, a lot of times our monoculture did better than, say, our mixtures in these cases. And I'm not trying to tell you to do one way or the other. I'm just showing you what kind of the research shows because a lot of times these mixtures can cost more. And so let's try to think about the value of each component. Um, and with that, one of the important things is for forage is our quality and our biomass. And so, taking a look at another study, this was done in the Northern Great Plains. I think it was in Montana. We had forage and they did forage quality and yield. And so the study looked at about 15 different cover crop mixes, and they varied a little bit between how many were in the mixture and how many were not in the mixture. I think it averaged between like 4 to 7 different cover crops in a mixture. And then they planted it at different times. They planted it what they said was the cool season, so earlier on, mid season, and then in the warm season, later in June, and they had barley as their monoculture control in this study. This was done in a wheat fallow year. And so what they saw was um, in biomass production, what they saw is the barley had the best biomass in that situation. I think it's a little bit unfair for this comparison because the warm season grass only had about a month, or the warm season um, cover crop setting only had about a month to grow. So we know if we give them more time, they're going to be able to produce more. And so really the fair comparison would be between our cool season and our barley, where they are at a similar planting times and harvest schedule. And with that, they also looked at that forage quality. I'm just showing you curd protein today, just for a quick show of what they were doing. And so, like I said, these were terminated in July. And so, if we were to compare against those mid-season and warm seasons, these are a lot less mature in their growth stages at this point. And so, we're comparing the cool season to the barley, we're still seeing similar forage quality aspects at this point. And so, when we're thinking about it, we really need to be thinking about the components that are going in. So barley was able to perform as well as some of these other cover crop mixtures for forage quality and biomass. And so to go back to that, kind of just thinking about how we should be thinking about these mixtures is, do we get enough of that cover crop to see its benefits? And so like I mentioned, we need 30% of dry matter of our legumes in our pastures to see the benefit of nitrogen fixation. Same kind of idea. A simple mix targeted for specific goals could go really well and far. Choosing a select number, maybe if weed control is your aspect, we want one or two species that grow very, very quickly, cover that ground as fast as it can so that those weeds don't have an opportunity. Nitrogen, legumes are a great opportunity for that. They fixate that nitrogen, and if you're going to plant it with the grass, trying to give it an opportunity to make sure that we're getting enough of that legume in comparison to the grass. Trying to plant complementary species with their growth form and period, trying to make sure that they're not competing with each other, but they are using their resources more equivalently. So, example of this is being able to having something maybe that's a little lower ground, uh, wow, lower growing and something a little taller growing so that they're kind of going for different um, resources in space and things like that. And so with that, we also need to be able to implement these into our systems that we have. And so what is our rotation? What rotation are we trying to fit it in? When do we need the extra forage? Especially when we're thinking about grazing, a lot of times we may not need it in mid spring when our pastures are super lush and growing very well. When does the cover crop produce well? And so trying to match those components to be able to fit our system. And so our typical forage system, we have our cool season pastures. And so in this chart, it's just a relative time, spring, summer, fall, winter, to relative yields. So a lot of times our cool season pastures grow really well in the spring and into the fall. And so knowing that, we're trying to fill gaps at other times of the year. If we don't have any warm season perennials, we have a gap generally here called in the summer slump time when those pastures start to decline. And so, how can we fill those extra gaps? And additionally, when we're thinking about this, if we're thinking about our calving seasons, typically we have a spring, fall, or winter calving season. When are our animals going to need that higher nutritional value? And we're going to need to make sure that they have that good forage quality. And so, a lot of times when we're breeding for the or when we're calving in February and March. So right before that, our moms are going to need going through that last trimester. But once they calve, they're going to have to be able to produce milk and sustain themselves. So they need some high quality forage at that point. And same with in September and October. So early fall, we're starting to look at, or later fall, as after they have those babies, we're starting to still need a bit more forage. But this is starting to get kind of outside of our normal forage production timeframes. And so, one of those ways that we can start thinking about fitting into that is those cover crops. Can we get enough fall biomass later on? Can we get it, or can we get it later on in the fall or earlier on in the spring? And so, this is our typical rotation. We have our corn and soybeans. They're planted in early May, harvested in late September, early October. Sometimes we have wheat in this rotation where we'll be planting that in that late September timeframe and being harvesting it in about early summer. And so these are kind of some typical rotations that we see here in the Midwest. Do we have enough time for fall grazing in this corn and soybean rotation? It's going to be tight. There's a very limited time frame from after harvest till we start to see our first estimated frost. And so maybe that's where our opportunity comes in with spring grazing and how these could fit. And so if we add cover crops to this situation, this is where those cereal grains really fall in well, especially cereal rye. It's one of the ones that's really well known to be able to take that short growing season and be able to produce biomass in the following spring. But we're able to go take that quick grow, that late planting, come around and be able to maybe be grazing that following fall. Now, if we have that corn, soybean, wheat rotation where that wheat's involved, we can actually start to see that maybe this is the period where we start implementing those uh, our cover crops, summer annual cover crops, those fast growing cover crops that really like the heat of the summer. There's a lot of opportunities in this to be able to get forage quickly. We could also be looking at getting some more forage, such as turnips, into with that earlier summer planting, trying to get some more forage quality. And so this is from the Midwest Cover Crop Field Guide. It's kind of an estimate of planting time to what kind of benefits you can get. And so it starts off with kind of a late winter. This is more frost seeding. It's where we're probably interseeding some legumes into the mix, and this is a really good benefit when we're thinking about um, for fixating nitrogen. We could be doing it midsummer. This again is something that we're thinking about after our small greens harvest. This is also something that a lot of people don't think about is prevent plant acres. This is a good opportunity to come in with a cover crop. We could be looking at still having some of those other cover crop benefits of improving the soil health, reducing soil erosion, and soil moisture. And a lot of times when we're thinking about this, quite a few different opportunities with our grasses, legumes, and broadleaves. And then if we're thinking about grazing these, we could be grazing these anywhere from late summer all the way to early winter, depending on what was planted. And um, I've seen a lot of people this with this type of opportunity, they do what's called swath grazing. They grow a summer annual, grows really well, and then they use it once or twice, let it grow out into the fall, let the frost kill it, and then they allow their animals to go in and graze it again. So a lot of different opportunities in that time frame of planting. Then we start getting into or late summer. This is following corn silage. So we're able to kind of start opening up that fall window a little longer giving more opportunities for different cover crops to be planted, maybe getting in a little bit of fall grazing. It's still a fairly short window, but we can start thinking about that a bit more. And then we have our early fall planting and our late fall planting. Early fall planting is really just thinking about interseeding right before harvest occurs, getting them in the ground, getting them starting to establish as the canopy starts opening up from leaf senescence. And so we're really thinking about, generally speaking, early spring grazing on this, and same with our late fall. Generally, a lot of people only recommend some of our cereal grains for that late fall planting following corn harvest because there's not enough time generally for anything else to be able to produce enough biomass to survive till next spring. Like I said, cereal rye is a very hardy and is one of the few options to grow with the limited time in the fall. Uh, there's been, yeah, and so this comment kind of here, real quick, is just to show in this study done by Bracy, they saw a 1 to 1.5 ton difference just with 2 extra months of growth. So that really shows the importance of trying to get a larger window open for them to be able to grow. This is just a quick chart for looking at our potential species, what they can be used for, and kind of a plant by date, just to get an idea of what that forage potential is in some of these crops. And so we could be seeing anywhere from 2 to 6 extra tons of forage using cover crops. That's an amazing ability, especially when we're thinking that if we weren't planting, that ground would be empty as is. Just real quick, these are some resources to kind of look at to see what kind of opportunity, to see what cover crops fit for you. This is Iowa cover crop fact sheets. They're online, but they can help aid in selection. You can have an idea of their cultural traits, what kind of planting times you need, what kind of biomass you may be expecting. Um, the, there's performance ratings for interseeding or overseeding, mechanical forage, grazing quality, and a lot of different other benefits. Additionally, we have our cover crop field guide. This can aid in selection as well. Is offered through the Midwest Forage Association. It has a lot more details on planting, termination, and a lot of extra information outside of just the species in this. And so now that we kind of talked about how we would select, how we would implement that in, we really got to be thinking about how we're managing these so that we're not impacting those other benefits of the cover crop. And one of the first things that you got to do is we have to be able to plant these. We have to get them in the ground. How are we planting? No-till drill is a great opportunity. That's going to ensure that we have good seed to soil contact for good establishment. We typically need a lower seeding rate in comparison to our other two options that I have on the slides. But there's generally a limited planting on like limited time frame that we can get these in the ground. So we have to be quick, especially if we're following a corn or soybean harvest. Aerial seeding, this is going to be a little bit higher of a seeding rate to ensure establishment, but we can interseed into a corn or soybean canopy earlier in the season, and that's how that benefit comes in. And then broadcasting, it's again another higher type of seeding rate, and we can get it into the canopy a little earlier in comparison to the drill. And so we might be able to establish those earlier, potentially get some more biomass going on. And there's many other new technologies coming out there to try to be able to get cover crops established sooner, what cover crops work well under the canopy. And so I'm excited to see that as they come out. When are we planting? So a lot of times, like I just mentioned, when are we planting? What are we planting? And so we have different opportunities with that frost seeding, getting it maybe interseeding those legumes into a cereal grain stand to help fixate more nitrogen, maybe improve forage quality. We have early season, trying to get that earlier season into the corn canopy, giving it a longer time to establish. Again, species are being studied to see which ones can withstand shading. Late season before the harvest, when the crop canopy starts opening up again, and then after harvest. So when does that fit in? And then we have our termination. How and when should we be terminating these crops? Generally, there's three ways that I think about cover crop termination. It's frost. Are we going to have winter kill? Are these plants going to be able to survive? So that's a simple way to know. I don't even have to worry about termination because winter is going to kill these plants. We have mechanical, so cutting it. This could be an opportunity for forage as well, cutting it for hay. We do need to make sure that we are cutting these. If we are using mechanical, that's just say cutting. Cutting may not be effective unless we're allowing them to get a little bit more mature so they don't regrow. And then we have chemical. The chemical is a very common way to terminate our cover crops. One thing I want to mention, and why I even have the slide is here, is grazing is generally not an effective method for termination. We normally don't get an even enough kill, and these plants will start to regrow. So we need to be thinking about another way to terminate. And also when we terminate is going to play a big factor. Soybeans, they're generally not as sensitive to our termination date. Basically, the cover crops should be terminated before crop emergence. So a lot of people are thinking about planting green now, planting into a living uh, cereal grain crop, but we should try to make sure that by the time those soybeans emerge, that cover is killed. Corn is a bit more sensitive. Thinking ahead, we should be thinking about terminating that 10 to 14 days ahead of planting. Corn, with that, if we have a high C to N ratio in those cover crops, that could tie up nutrients for longer for corn establishment. So thinking about if we are in a shorter window, thinking about a applying nitrogen, a starter nitrogen. And then my thing that I like to think about, particularly when I'm thinking about grazing cover crops, is when can my animals return to a perennial pasture? How long do I really need these animals to be grazing this cover crop so that I'm not limiting one, maybe the row crop production, but two, especially if we're thinking about spring grazing, spring grazing, though our perennial pastures, when they start to take off, we're going to get this really large spring flush of growth. So when are we able to transition over? Do we need to keep them on until June? Probably not. We probably can be able to switch them over to our perennial pasture sooner, unless we are in need of more forage for some reason, environmental, or we have more animals than expected. And so when we're thinking about our grazing considerations, are we grazing these once or are we grazing these multiple times? Are these going to be able to regrow or are we basically waiting? Are they going to be winter killed and we're only grazing one time? And so just really being able to understand that's going to kind of play into a role of how we should be thinking about managing these and our water location and when will this be grazed. All of these factors are going to play into an effect and they do differ to our perennial pastures. Cover crops, generally speaking, we are thinking about grazing them this 1 year. We're either we're terminating those cover crops following. Perennial pastures, we're thinking about grazing them for multiple years over time. And so we want to be able to utilize them to our best of our abilities in the time frame we can. They differ, but they are also similar as well. And so when we're thinking about these grazing strategies, we're thinking about where is our forage productivity. Can we get uniform manure distribution to try to have a uniform distribution for the following row crop, forage utilization? I think being flexible is important in this because if it decides to rain and it is a complete mess out there, we might need to move our animals to a sacrifice lot during that time. We want to avoid compaction areas. Water is one of those. They like to hang around the water and moving around. How are we extending the grazing season? And we want to minimize our impacts on crop productivity and our cover crop benefits. And so when I'm thinking about grazing cover crops, we really were thinking about implementing that rotational stocking type system, moving the animals around to uh, better distribute the manure, better forage utilization. Then we have our strip stocking. This is when I'm thinking about grazing something that we're only grazing one time because maybe it was winter killed and we're grazing it after that fact. So we can move the fence forward and we don't need a back fence because in this photo, once this fence gets moved forward, these cattle are instantly going to go to greener pastures and graze that area. They're not going to back graze as much. And so thinking about what kind of opportunities you have in those situations. And then just some kind of I'm kind of running low on time. I want to make sure there's time for questions, but uh, grazing management. When should we move our animals? Stocking rates, how many paddocks, and what should we avoid? Because we got to be really be thinking about this is a single part of the system. And so when we should be moving our animals, a lot of times in our uh, cool season cover crops, we're thinking about starting grazing about 8 to 10 inches and moving them by the time they get down to 3 to 4. They're quick moves, trying to keep animals from being on a certain area for long periods of time. Estimating that stocking rate, really trying to match the number of animals to the forageability we have. Higher stocking rates can lead to that compaction problem. Um, Paddocks, being adaptable on how much area is given, trying to keep these moves pretty short, trying to keep them moving around the pastures is beneficial. We do want to avoid grazing when wet. This, like I said, we don't want pugging in the fields. This was one of the concerns that the paper did notice. Tillage can't help with that, but having a sacrifice lot, moving them off, and then overgrazing. Overgrazing can cause a lot of different problems in our perennial pastures. It can cause a weakened stand that can't survive multiple years. In cover crops, we're thinking about overgrazing can open up opportunities for weeds to come in. They're opportunists. They come in during that time when we're show that soil. Also, having too many animals in one area, leading to other problems. And so, just real quickly, I just want to mention that there are toxicity concerns in our cover crops. We have many legumes that can cause bloat. And so, all of these things are aspects that we have to be concerned about, generally speaking, with just our normal forages. But specifically, our sorghum species, they have the prussic acid. When we're thinking about that, just avoid young plants and avoid them after they've been frosted. That's kind of the two time frames that I really think about when prussic acid is a major concern. Our brassicas can cause a lot of different problems, but this one specifically, I'm not going to say the name, but I'm going to call it PEM. It can cause blindness, aimless wandering, and twitching, eventually death if possible. So potentially, and so just if we have brassicas in our mix, we try to be thinking about them being less than 70% of the diet, so that these problems don't occur. And then we have nitrates. Nitrates can occur in so many different of our cover crops. We have our warm season annuals, our cereal grains, our brassicas. But it's just being smart around them. If the plants are stressed, giving it an opportunity to come out of that stress before utilizing over fertilization, and then extended periods of cool and cloudy weather. Really just paying attention to when we're grazing and how we're grazing. And so, just for some final thoughts, when you're starting with cover crops, thinking about what are your objectives? What is your cropping rotation? Where are you located? And when do you need more forage to be able to uh, fit your operation. And what pesticides have I used? I didn't really get into this, but just making sure that we don't have plant back restrictions that are causing problems for the cover crop we're going to have. And just real quick, are there any questions? Sorry, I kind of went right up to time.